disproportionation or opposite to the disproportionation is called what? Comproportionation. In this case, an element of two different oxidation states. Element is having what? Two different oxidation states. And that converting into, that means they're combining into, give single product, one product. Let me do one example, easily it will understand. So here I have taken Ag, I have taken Ag0 beta. I have taken Ag plus 2, I have taken Ag0, both I have taken. Now when they do undergo oxidation, I got Ag plus here. See, an element, see, with the two different oxidation states. One is plus 2, other is 0. They both are combining, you see, both are getting combining to give a single product. And this single product will have intermediate oxidation state. Now what is the intermediate oxidation state for plus 2 and 0 beta? What is the intermediate oxidation state for plus 2 and 0? Between, middle. Which one beta? Between plus 2 and 0.
Plus 1.
Plus 1 only. You got plus 1. You see. This is the simple reaction you can take here, right? The comproportionation means opposite. See, opposite means you see plus converting into 0, reduction, plus converting into plus 2, oxidation. Opposite is nothing but disproportionation. So whenever if you take opposite reaction of disproportion, that can be called comproportionation reaction, in which an element undergo, isn't it, combination, in which two different oxidation states will be added to give single product which has an intermediate oxidation state. So this is the definition and examples, right? Now we can also observe here what how it is undergoing redox. Also we can easily observe here. In this case, 0 converting into plus oxidation and plus 2 converting into plus 1 is called reduction. It is also redox concept here. So this is about the comproportionation reaction beta. So before starting balancing reactions here, balancing of redox reaction, let me discuss some oxidation numbers for peroxy acids beta. Some peroxy acids are there. Let me discuss that further. We start balancing of reaction tomorrow better. But before that one, let me see some reaction beta. Now if I take what? H2SO5 beta. H2SO5. Now what is the sulfur oxidation state beta? What is the oxidation state of sulfur beta? Anybody?
-2.
Yes beta, कितना आया?
-2.
जोर से बोलो. 2 हाइड्रोजन्स प्लस 1. बोलना है, किसी को बोलना है, बोल दो बेटा.
+8.
+8, very good. 5 oxygens are there here. Each oxygen carries -2 is equal to 0. Now sulfur will get how much beta? +8. But when we discussed about the oxidation numbers in the previous classes, I told you the oxidation number must be less than or equal to its group number. Now sulfur group number कितना है बेटा? Anybody? Sulfur group number कितना है बेटा? 6th A group number. Otherwise 16th group, but I will take 6th A group element. Now sulfur can exhibit maximum कितना है बेटा? Less than or equal to what? 6 only. Sulfur cannot exhibit its oxidation number more than 6. Why? Because its group number 6th A. 6th A means how many valence electrons it has? NH2, NP4. So total how many electrons it has beta? Only 6 electrons it has. Now if you have 6 electrons, how many electrons you can lose beta? If you have 6 electrons, how many you can lose beta? More than 6 is possible?
No sir.
अगर आपके पास 100 रुपया आपका जेब में है बेटा, तो आपने किसी अपने ग्राउंड में खेल रहे हैं, बाद में वो 100 रुपीस गिर गया, तो आप किसी को आपका पेरेंट को बोलते हैं मेरा 150 रुपीस आई हैव लॉस्ट 150 रुपीज, ऐसा बोल सकते हैं आप? आपका कितना पैसे हैं आपके पास जेब में? 100 रुपीज ही हैं. You can lose only 100, more than 100 is impossible here. So here also sulfur valency electrons 6 only. Therefore it can lose only valency electron, that is 6. So sulfur cannot exhibit more than 6 in its oxidation number. That means this formula what we are taking is not applicable because it is peracid. It is a peracid. Why? Because why we got mistake here? We done a mistake here. Now anybody tell me, in peroxide what is the oxidation state beta?
-1.
Oxidation state in peracid or peroxide always will be
-1.
Now don't take here -1 beta directly. Don't take here -1 because there are 5 oxygens are there. Now all oxygens are not in peroxide. Some are oxide, some are peroxide. Now how to know how many are peroxide, how many are normal oxide? In that case, you should know the structure like this. S double bond O, OH. Here it is what? S double bond O, OH. Now this is the structure of what? Persulfuric acid. Persulfuric acid. Persulfuric acid. Now here these two oxygens are having -1. There are peroxide. Generally peroxide looks like this beta. Peroxide is nothing but OO linkages are generally called what? OO linkages are generally called actually what? Peroxides. They are called what? Peroxides. Now where you are having OO linkages here? Here it is. So there are 2 oxygens are there which are having peroxides, and remaining 3 oxygens are nothing but what? Oxide. These 3 are actually what? Oxides here. Now move to formula now. Now first of all we'll see there are 2 hydrogens are there, +1 charge, plus sulfur. There are 3 oxygens are there whose charge is what? -2. There are 2 oxygens are there whose charge is what? -1, that is equal to 0. This is for peroxide and this one is for simple oxide. Now when you do the problem, how much we get? +2 sulfur -6 -2 is equal to 0. +2 -2 get cancelled. Now sulfur is equal to what here? S6. In this way we need to do it. H2SO5, the oxygen state will be +6. Now here, how to identify it is? How to identify whether the given molecule is peracid or not? Whenever if we get an oxidation number more than its group number or more than their valency electron, then definitely they are what actually? Peracids. How to identify? Whenever oxidation number is more than what? Their valency electrons. Valency electrons is nothing but outermost orbital electrons. In this case only, isn't it? You will get peroxides. All of you note down this better. The structure you note down and this formula you note down. And this note down this one also. Now I will check, already I told you I will check your notebooks when you come to what? Exam. Offline exam will be started after 15th onwards. So I will check all the notebooks. When you come to the school, you have to submit your notebooks compulsory. Second thing that that portion, just we reduce that portion, we are not giving hydrogen compounds beta, only redox concept. Up to redox concept, we have to practice. Starting onwards, up to redox concept. Meanwhile, one chapter is there, equilibrium. You leave it that equilibrium. Except equilibrium, first book. Complete first book, except what? Equilibrium chapter, 7th chapter. Now, shall we take one more structure beta? Is it finished? Shall I move to what? Finished beta? Right. Now,
Yes,
I will
sir.
take one more structure beta. I will take one more structure here. H2S2O8 beta. H2S2O8. And try this here also, how much you're getting better. Try this one. This is called Marshall acid, paraxy disulfuric acid, paraxy disulfuric acid. The previous one is paraxy monosulfuric acid. This one is what? Paraxy disulfuric acid. The previous one is H2SO5, paraxy monosulfuric acid. And this one is what? Paraxy disulfuric acid. Now try this one, how much you are getting sulfur beta?
7.
So 7 is possible beta. Is it possible? Because sulfur valence electrons kitna hai beta? 3s2, 3p4. So 6 only. So definitely we have to change something. So here what we have to change here, out of these 8 oxygens, 2 oxygens will be -1 beta. Then you will get the answer. Here no need structure, but we can, without structure also we can do. Because once if we know the previous one, the same thing we are applying over here. Same thing we are applying here. Like this. Now here these 2 oxygens are having what charge beta? -1. And all remaining are having what here? -2. All remaining are you are having -2. So what is the formula now here? 2 into +1. This is for hydrogens. 2 hydrogens plus 2 sulfurs plus, out of these 6 oxygens are having what? -2, and 2 oxygens are having -1 is equal to 0. So we are getting what here beta? +2 plus 2 sulfur -12 -2 is equal to 0. +2 -2 get cancelled. Now 2 sulfur is equal to +12. Now sulfur will be what? +6. That means whenever if we get what? More than their group number, more than their valence electron, you take that as a peroxide here. And out of these 2 oxygens you take -1. Okay. 2 oxygens will be -1. And all the remaining you take as -2. You will get the answer here. So this is actually what for peroxides you can do like this. If you have any doubts regarding any oxidation number, you can speak now, you can ask now. I will explain. If you have any doubts, you can ask me better now.
No, sir.
बोलो बेटा. You try this problem, 8.5 all of you. After the class, you write in the notebook. This you take as a homework here. Already answer is there. You read the answer and take it down. This one. 8.6. Take as a homework beta. Classify the different type of redox reactions. You have to classify that one. A is what type of redox reaction. B is what type of redox reaction. Okay. There are some answers are given. Just copy that one. Now, apart from this one, let me discuss some other values also. Paradox fractional oxidation numbers. Some more examples are there here. Let me take the first one, carbon suboxide beta, C3O2, carbon suboxide. What is carbon suboxide means? You can write like this beta, C, double bond C, double bond C, double bond O, double. Now what is the meaning of suboxide means? See, generally beta for 3 carbons, only 1 oxygen is there beta. Generally if you observe carbon dioxide, for 1 carbon there are 2 oxygens are there. Okay, for 1 carbon there are 2 oxygens are there. But here 3 carbons, there are only 2 oxygens. Means this is what oxygen deficient it is. For 3 carbons, only 2 oxygens are there, oxygen deficient. So for them you can call suboxides. Whichever are having less deficiency in their oxygens, they are called suboxides. Carbon suboxide can be written like this. Now if you observe the middle one beta, middle one, is it having in same environment or different environment beta? This middle is carbon. This carbon is having in same environment or different environment beta? The middle carbon, this one, is it having in same environment or different environment? Do fast beta. We'll conclude this here only. Do fast. If you do fast, what happened? We can conclude here only. Yes. Same or different beta? Are you there?
Yes, sir.
Now tell me, different or same? How it looks?
Different.
How it different beta? Here's double bond C, here a double bond C, here a double bond O, here a double bond O. When it is in same carbon is there. Can you write difference in the, can this carbon this carbon is having more, like can I write this carbon has more electronegative than this carbon? Can I write this carbon is having more electronegative than this carbon? Is it possible? Impossible. So this carbon is in symmetrical environment. So in this case, one element is unable to have what? Accepting the electrons from the other element. Impossible, because both are in same environment. For example, if I write iodine and iodine, can I write positive charge in this? Can I write like this, positive, negative? Is it possible better? Impossible, because when both are same, for example, if you have HCl is there, you can write here negative charge, you can write here positive charge. You can write like, because they're difference in their electronegativity, but here they're same. So when they're same, what happened? You cannot develop the charges. Polarity cannot develop here. So that is the reason the oxidation number for this carbon taken as 0 here. Here it is taken what 0. Next, for always oxygen, how much better? Because oxide. So what I have to take here? -2. If it is -2, definitely the cation will be how much better? +2. Again, same oxygen is what? -2. If it is negative charge is -2, positive always will be. Otherwise, you can take number of bonds here. How many bonds are there better? 2 bonds are there. Take 2 here better. Then among carbon and oxygen, which is more electronegative better? Among carbon and oxygen, oxygen belongs to 4th year group element. Oxygen belongs to 6th year group element. Higher the group number, in same period, higher the group number, it will be more electronegative. Which one is more electronegative? Oxygen is what? More electronegative. This one. So in this case, you got like this. Okay. Now, if I do take what happened, bromine here, Br3O8. Br3O8. It is not suboxide because you have plenty of number of oxygens, so excess of oxygens are there. Now, how to identify the oxidation number better? See, bromine, you can't take anything better. Bromine, don't consider anything. Leave it that. Now, how many oxygens are there better? 1, 2, 3. Each is having what? -2, -2, -2. Now, overall, how many negative charges are there better? How many negative charges are there here? Overall, this side.
3.
3 negative charges are there. Total negative charges are how many better? सभी लोग नींद में है शायद. कितना ओवरऑल नेगेटिव चार्ज बेटा यहाँ पर?
-6.
So कितना आएगा आपको यहाँ पर? +6 आएगा. If it is -6, bromine will get +6. Same thing here also. Same -2, -2, -2. So on bromine, total negative charges are -6. So bromine will get here +6. Bromine will get here +6. Now here how many oxygens are there better? -2, -2. Now bromine will get what? +4. Next, coming to here, what happened? S4O6 -2. Now sulfur, same thing, 0, 0. Now if you observe sulfur here, how much oxygen state you are having here? How many bonds you are having? 1, 2, 3, 4, 5. So +5. Here also 1, 2, 3, 4, 5, +5. So in this way, we can calculate the oxidation states. So here, the oxidation state of this sulfur is different. The oxidation state of this sulfur is different. But oxidation number means take average value. Average means +5, +10. Okay, +10. And total 4 sulfurs are there. Divide by 4, you will get 2.5 is the oxidation number in this. Oxidation state is different. Here sulfur is +5, here sulfur is +5, here 0, 0 like that. In this way, we can write n number of examples. Coming to what happened, Fe3O4 here. Fe3O4. In this case, can you say what is the oxidation state of iron here? 3x, then 3 irons plus what happened? 4 into -2, that equal to 0. And 3 iron is equal to how much beta? +8. And 1 iron is equal to how much beta? 8/3. 1 iron is equal to what? 8. Average value it is. Average value. So oxidation number कितना है बेटा यहाँ पर? Plus 8/3. But actually, do iron exit plus 8/3? No. So actually, Fe3O4 I can write like this: FeO plus Fe2O3. Add these two, what happen? We get Fe3O4 beta. Now Fe3O4 is nothing but what? Is a mixture of what? Iron oxide plus Fe2O3 plus Fex, ferrous oxide, ferric oxide beta. Now in this case iron oxide state कितना है बेटा? Anybody? आयरन का कितना हो जाएगा यहाँ पर? +2. यहाँ पर कितना हो जाएगा आयरन का? 2 आयरन्स plus 3 oxygens, 1 equal to -2 is equal to 0. Iron is what here? That means in Fe3O4, one oxygen, here it is. One iron is having what? +2. And the 2 irons here. See the 2 irons here. 2 irons if you have. The 2 irons, they're having each are having +3. Each are +3 and +3. So in this way, you have to write the oxidation numbers for what? This type of mixed oxides. Similarly, MnO3O4 also same like MnO3O4. MnO2 plus MnO. Now take care what? 2 moles here. 2 moles of MnO plus MnO2 can be taken as Mn3O4. Pb3O4 also same thing. PbO plus PbO2. Take 2 moles here. Take care what? 2 moles plus. This one is called what? Pb3O4 beta. Now you take this example as a homework beta. Calculate the oxidation state of lead here and here. This will be +4. This will be +2, but you have to calculate in this manner. Just like given like that, but you have to calculate in this manner. This is about the oxidation numbers beta. Understood here? And tomorrow class, we'll discuss about the balancing of the reactions beta. This balancing we'll discuss here. Okay? Now if you have any doubt,
Tomorrow class is at what time?
tomorrow class I will take at 9 o'clock beta, regular time, generally beta. Wednesday, Monday, Wednesday, Friday. Monday, Wednesday, Friday. We will will take class at 9 o'clock. Sorry, 1 o'clock, 1:15, because exams are going on. No.